Hello everyone, my name is Nick and I'll be walking you through how to do a Bitcoin full node installation on a Linux machine. I'll be doing this demonstration on Ubuntu 20.04 Focal. This video is for anyone that is new to Linux, new to Bitcoin, and wants to learn more about the technology and help support the network. So this demo is broken down into 4 key sections. First one being PGP Key Verification. Then we'll talk about directory creation, downloading files, and signature file verification as well. Third thing we'll be discussing is install and running the btccore on your machine. And then the fourth thing is we'll create a simple bash folder for your desktop. PGP Key Verification confirms that the package that you're installing on your system is in fact signed by the developer who wrote it. It reduces the likelihood of installing malicious packages on your system should the hosting website you're downloading it from become compromised, and it's generally good practice for validating all packages, especially those that are not downloaded from a package manager like Advanced Packaging Tool or APT in Ubuntu or DNF in Red Hat Fedora. So what I mean by that is if you download this, let's say in this instance that BitcoinCore, bitcoin.org has been compromised by a malicious actor and they have put some malware here for downloading. PGP Key Verification is going to help you detect that if this is if the Tarball that you're going to be installing on your machine, the compressed file that you're going to be installing on your machine, whether or not it's been compromised. That is why we do PGP Key Verification. If you get something through a package manager like Advanced Packaging Tool that Canonical runs from Ubuntu, those are pretty clean. There's a process for writing code that's verified and it's managed. Not saying that you shouldn't do it, it's just a lot less riskier than if you got something out in the wild. So doing PGP Key Verification, it's pretty important if you're downloading third-party software, and that's what we're going to talk about here first. So the items that are used in PGP Key Verification are the fingerprint, and all the fingerprint is a shortened code. It's a shortened code from the public key, and it's used to query a database on a key server. And what happens is that you take the fingerprint and you query the key server, and it renders back the full public key. And this is the release signing key. For all intents and purposes, it's a public key. And you take this public key and you use this public key to verify the signed hashes. Now, the signed hashes are basically the signature of the author, and they're derived in a couple different ways. The first thing that happens is when the developer is done with their code, they'll run it through a hash, 256 hash. They'll take that hash and they'll encrypt it with their private key, and that'll get you an encrypted hash. That encrypted hash is subsequently commingled with a public key to get a digital signature. So the signed hash is the item, the target that we're looking to validate. And if you notice here, you see the public key is there. That is what we're looking to pull here from the key server, the third-party key server, to validate the digital signature. So let's get a graphical view of what that looks like. So you have your fingerprint. It's a shortened, for all intents and purposes, a shortened public key. You go out to Ubuntu. Ubuntu queries it using the fingerprint and renders back a full public key. That public key in turn is used to verify the signed hash. And once we know the signed hash is good, it doesn't mean what you downloaded, the file that you're going to install, is good. It just means that the signed hash is signed by the person who provided the fingerprint. So we took the fingerprint from the website, we queried it, the Ubuntu key server, we got the public key, we took the public key, we validated the public key against the hash, and we found out, hey, the public key was used in the digital signature. This public key here was used in the digital signature that we have provided, that we got from the site as well too. So it's just kind of using a trusted third party, which is Not verbiage that we use a lot in Bitcoin, but it's useful when we're talking about PGP encryption, PGP verification. So that is at a high level what's actually happening. And we're actually going to do this, but I just want to run through the theory first so you guys have an idea of what we're talking about. So when we go back and actually start doing this, I'm going to reference back to this this picture here so you guys can see, and we get a better understanding of what's actually happening here. It's not really a topic that a lot of folks cover, so thought it was germane for this presentation. So then after that, we're going to verify the Bitcoin Tarball. We know that the SHA-SUM 256, or this signed hash, the SHA-256, the signed hash file provides a good signature. We want to match that signed hash that we got from here to the BitcoinCore Tarball, because the BitcoinCore Tarball has the same digital signature, should have the same digital signature as the signed hash that we have, the list of signed hashes. They should match out. And if they match out, then you're good to go. You can download this onto your system without major concern. So let's go ahead and do that. Let me go ahead and get this cleaned up first. All right, let's go ahead and talk about that, how we actually create the directories and download and verify. So the first thing I'm going to do, I'm in my home directory. Anytime you see this tilde, it means that you're in your home directory. So I'm going to change directory to desktop, and now I'm going to create, I'm going to mkdir, make directory. I'm going to call it btccore. Now you can call it whatever you want. I'm calling mine btccore. And this is where I'm going to put both the files, both the BitcoinCore and the release signatures, the signed digital signatures, into this file, into this directory. So I list it. You see btccore is there. So let me go ahead and download both of them. I download btccore. It's the Tarball. And I'm going to download the release signatures. Now you'll see down here that BitcoinCore provides the signing keys, and this is the public key that we're going to query and get from, just double back here. This is the sign key that we're going to get from the key server, but they provide it on the site. Now if you think about it, it doesn't make a whole lot of sense to validate against what they provided on the site, because if this is compromised, then everything's going to go with it. The core, I mean, this will be gone too. Like if you're not querying against, if you're not pulling your public key against from an actual third party, it doesn't make sense, because then if the whole site's compromised, then they're just going to put a bunch of, they'll sign their malicious code with their private keys and provide the public key here that corresponds to that private key, and it doesn't make sense to not pull from the server. You should pull from the server. So we're going to go through that route. I'm not going to waste time and download BitcoinCore release signing keys. We'll get those from the server directly. So let's give it a couple minutes to download. It depends on how fast your system is. Actually, let me see. It might be already be done. Let me see here. Change. No, it's good. It's done. We don't have to wait. So, all right. The next thing we're going to, so we're going to copy the PGP fingerprint. Now, we got the fingerprint from here, Bitcoin.org, and here's the fingerprint. This is the latest 11.0 one. This is the fingerprint right here. I've already put the fingerprint into these instructions right here. They also provide it on bitcoin.org as well too. I just make it as simple as I can, as far as just it's clean, concise steps, and they'll all be in the description below. So we copy this, put this into our terminal, and what I'm doing right now is I'm importing the fingerprint. Importing the public key. So I'm doing GPG, which is GNU Privacy Guard. That's the command. Option is -- long form option. That means I'm writing out the whole option. If it was one dash like a K, then that'd be short form. But this is long form -- keyserver HKP, which is HTTP key block protocol, I think is what it stands for, keyserver.ubuntu.com, and receive RCV keys. I'm going to receive keys that correspond to this fingerprint. Let's go ahead and do that. Great. So we called out to the server, and they responded back and provided us with the public keys. And just for everybody's edification, not that this matters, but just so you can see, this is where the public keys are stored on your file system. So just change directory back to home, and it's stored in a hidden file, and hidden files are always have a dot in it. So if you want to list them all out, you press LS for list, then you put the A option in for all, and it's going to show you anything with a dot here is a hidden file. So this one is hidden specifically in gnu.pg, so I changed directory.gnu.pg, and this pubring.kbx is where all of your public keys are going to be stored, just for everybody's edification. Not that it matters, but if you want to know, that's where they're stored. And we'll go ahead and go back to the BTC folder, change directory, BitcoinCore. Alright, cool. Alright, and then the next thing we're going to do, so just references back again. So we queried it, we got the public key, this is where we're at right now. Now we're going to verify. So how do we verify? We verify by calling GPG again, that's the command. We put -- verify, and then I'm going to verify the SHA-SUM 256. Again, these instructions are in the description, but just so you know what we're doing, I'm taking this public key that we just downloaded from the key server, and I'm verifying it against the signed hash. Remember, signed hash has public key in it. So there's an algorithm that's done to create the digital signature that includes the public key. So that's what I'm doing. I'm verifying the public key here matches the signed hash here. Great. So we get this return message here, good signature from Wladimir J Laan, and that's good. You'll see this down here, this key is not certified with a trusted signature. So that's beyond the scope of what we want to focus on for this recording. It's not something that we need to do unless you're going to be talking back and forth with the author. And the way that you would get it is to add it to a trust, you would sign their public key with your private key and add it to a trust, and then you wouldn't get this error, but it's not relevant for what we're trying to accomplish here. So we have what we need. All right, great. So let's go ahead and we verified it. It looks good. Signature is good. Now the next thing we're going to do is verify the downloaded file. So I'm going to type in the command. I'm going to verify this Bitcoin Tarball right here. This is the actual code file. I'm going to verify that. So what I do by verify it is that we know the SHA-SUM is good. We just need to compare it with the signature, the digital signature that's on the actual downloaded Tarball, and that's what we're doing right now. So I'm going to open another terminal so you can see, and I'm going to go ahead and I'm going to just go ahead and put cat here and open up the 256. So I'm going to cat SHA-256. I'm going to open up the SHA-256 file, and I'm going to see the digital signature for my specific system. So my system is a 64-bit Linux. That's my digital signature, right? So this digital signature we validated through the key server. We know this is good. We have to check it against. This should match up exactly with the digital signature that was used to sign the Bitcoin Tarball. So let's go ahead and do that real quick. So we change directories back. This is another terminal just for clarity's sake. and then I'm going to do the command. I'm going to do SHA-SUM dash option A 256. So SHA-SUM is a standard util as well, standard utility. Dash A, saying algorithm 256. That means give me the digital signature for 256 hash for this tarball. And what does it provide me? It provides me with the same exact signature as what we have in the SHA-SUM file. So we see here, SHA-SUM provides this EB2, last 3 digits EB2, and the Bitcoin Tarball provides digital signature that is exactly the same. That means that this is a confirmed good file to download. We don't, it's not been compromised. So the key is that we took those fingerprints, we queried the key server, we got our public key, took that public key, we validated the public key we validated the SHA-256, the digital signatures, against the public key. We found out, hey, that digital signature is good. Then we took those digital signatures and we validated against the digital signature that was on the tarball, and they match, and it's fine, and we're good to go. Hopefully that makes sense, but that's where we're at right now as far as PGP goes. So we know the file's good, we're ready to install it. Let's go ahead and move forward. I'm gonna go ahead and clear my screen. I'm still in the same directory. All right, let's do the initial block download. So the next thing I'm going to do is unzip it. Now, there's just another standard utility called a tar. It's a tape recorder, I think what it stands for. All it is a compressed file. It's a zip file for what we're talking about. And you pass that to unzip. You pass in, you call the command is tar. Option is XZF. And that stands for extract zip file. So you can do it that way. You can do it this way as well too. But it's just cleaner if you do it this way. And all these, like I said, they're on bitcoin.org, and they're also going to be on these subscriptions as well too. So I'm going to do a tar XZF Bitcoin tarball. I'm going to extract it, and boom. What do we see? We see a new directory here. The Bitcoin directory is here. So that's great. So this directory right here, this Bitcoin directory, is where all of our code is, all of our binaries that we need in order to run the BitcoinCore and run the full node. So in order to keep that, because they're in a local directory on my desktop, I don't want to keep it there because there's updates. A lot of stuff happens on the desktop. A good sanitary practice is anything that you have that's a third-party installation should go into your user-local-binary bin, right? So it's this command right here. It's going to be sudo install. M is, let me go ahead and just show you right here. Just do it real quick. Just copy and paste it. So it's sudo install. The M option is like a change modifier option, and this is an octal value. It's 0755. Octal value, this is just given permissions, right? So the first two numbers are for the user, the second one is for the group, and the third one is for others. Now don't worry so much about what the octal values mean, but you do need to know that 7 stands for read, write, and execute. That means the user will have the ability to both read, write, and execute. 5 means for the group that they will have the ability to read and write, and the other 5 means for the other that they'll have the ability to read and write. So 755 means that you're giving the user full command to do everything, and everybody else has read and write permissions. You want to then go to -O, which is owner, the option owner. You're going to assign it to root, group, root, and the target is going to be your user local bin, and you're going to create this right here, this Bitcoin -0.21 bin directory. So let's go ahead and press enter. We'll put our password in here. All right, great. So let's go ahead, let's double check that's there. I'm going to go change directory -user-local-bin. And you see, it's beautiful. All the binaries are there that we need to execute. So there's 6 primary binaries that are going to be running in Bitcoin. Your CLI, your command line interface, your daemon. The one that we care most about is the Qt. That is the actual graphical interface. So, and as these videos progress, we'll talk more about command line, that sort of thing, how to set up wallets and configure it so you're actually supporting a network by allowing incoming and outgoing traffic, getting your Tor configured. We'll do all that later. Those are for later videos. But for right now, it's good to know that we have the BitcoinCore on our local bin, local directory. Back real quick. And you'll see a user here too. Like, you'll see the 2 big things are, just for everybody's transparency here, you have local, and then you have share. And share is all the stuff that comes, change directory share. It's either share or local, usually for programs. And share is the stuff that you get from your package manager. It's what you download initially when you do the initial installation of Linux, but it has a bunch of stuff in share. See? All right, so let's go ahead and go back. Excuse me. We're in user. We go to change directory local, and we have our binary. So and then if I want to start running the initial block download, right? I do execution of that is /bitcoin-qt, and boom, now this will pop up. And if you're truly going to run a full node, it's 400 plus gigs. This at least 356 will be stored in this directory. So all your blocks, you need to find a place to put your blocks. Now, my system's 120 SSD, 120 gig SSD, so I can't keep it on my local system. I don't want to run a prune node. I want to run a full node so I can really support the network. So how do I do that? Is I put it onto a external hard drive, and that's what I'm doing right here. So even though my code is going to be on my local, on my desktop, all the blocks, all the heavy blocks that are being validated against will go onto an external drive. So do that, and it kicks off. Awesome. And just for transparency, where that is located, the external hard drive's always located on the Linux file system. Usually it's on the media, and media is always found on root. So you change directory, list it out, you see media down here, media, you change directory to media, ls, change directory to my username, reserve, ls, Samsung T5, that is my external drive, so change directory Samsung. And you see BTC blocks, change directory BTC blocks. And you'll see the blocks start showing up. They show up as .dat files, and there'll be bunches of them if you let this thing run. And that's the whole intention, is getting this thing spun up. So this can take a couple days to download the full block, the full node, if you will. Highly recommend, if you use an external drive, get an SSD. It's faster. But again, use what you got. If you wanna just mess around with it, you can prune it, and I'll show you how to do that later on. But for right now, we're downloading full node. All right, great. Come this far. This is good. So let's go ahead and talk about how we're going to create a little bash script that's going to let you just double click on your desktop to get the node running. Let's go ahead and shut this down real quick. Going backwards. All right. So for bash script, I'm going to go ahead. I'm going to get my text editor, whatever you want to use. I think it's just like a generic notepad. Doesn't matter. Yeah, text editor. And then you just want to save it locally. So you save it to your desktop, and I'm going to call it BTC. Save it, desktop. I'm going to call this BTC full node .sh. sh is the shell script, so save it as that. All right. Type the following in. You want to put hashtag ! That's called a shebang. /bin /bash. And this is basically going to tell you, /bin/bash. That's going to tell the system, tell the Linux operating system that this is in fact the shell script you need to run. Change directory usr-local-bin, then ./bitcoin.qt. I'm going to save this. All right. And now that I saved it, it should show up on my desktop. Where did I save it? Sorry about that. Let me see here. Lost my train of thought. Sudo update db. So sudo update db, I'm going to use locate command to find where I saved this. So updates the database. I'm going to use locate, locates local cache, and I'm going to search for btc fullnode.sh. Home reserve. It's on my home file. It was on desktop. All right. Change directory. So that's how you locate stuff. You use find command as well too, but I use locate. It's a little bit something I just prefer. But find's usually more verbose and better. It doesn't use as much system resources. So if you're doing like major administrative stuff, always use find. If you're doing just local quick stuff, update your database real quick, your cache, to use locate. All right. Change directory to, and then I want to go ahead. I'm gonna just go ahead and move btc full node. That's how you move it to the desktop. So learn other commands. All right, there you go. Cool. Now it's on desktop. So if I click on it, nothing will happen. It just opens up. It doesn't execute. And why is that? So if I open this up and I go to here and I go to permissions, right? Preferences. Excuse me 1 second. I go to properties. It's not showing my properties. Why not? Preferences. Yeah, that was right. No. I never know what this stuff is on the actual GUI. Let me see here. Bear with me. I'll find it. I'm sorry. Let's go ahead and just do it. Let's just make this executable. So what I'm going to do here, guys, and I apologize. I should know that, but I don't use the GUI at all, ever. But let me go ahead. Excuse me. We'll go ahead and change this into an executable. We're going to change directories, the desktop, and I'm going to type in chmod plus executable. And I'm going to call this btc chmod plus executable btc full node. Actually, btc full node. Full node. There we go. And you see it's right here. Now it should be executable. So just double click on it. And nothing happens. What am I doing? Properties. Other applications. So let's double check our path real quick here. cd usr/local/bin. That's probably what it was. Just slash there. cd users. Yep. Try that now. Boom. There it goes. All right. After some consternation. So, what I did is how it runs. So what I did is I did a ch mod on it, change modification. Use change modification. You plus X, that means make it an executable. Then you put in the name of the file, BTC full node, and that turns it into an executable. That way, when you want to run it, just double click. Full node comes up, starts running. Awesome. So that's what we have for this video, guys. Hope you enjoyed it. Please leave your comments below, and we'll look to have the next video about getting the full node fully configured and allowing incoming and outgoing messages as well. If there's any questions, feel free to reach out to us, and talk to you all later. Take care. Bye-bye.